Good afternoon, ladies and gentlemen, Precalculus. We're going to be working on section 2.8, which has to do with polynomial inequalities. So we're going to just do these exercises, which in effect are preliminary to that. I'm going to choose names randomly too to help us out through this. Well, right here, use limits to state end behavior of the function. And what did we talk about? Remember what we talked about that was this thing right here? This
even, odd, odd.
Odd, even. Remember that?
Yeah.
Yeah, you don't have, oh, yes, we do have the cheerleader here.
Yeah.
You were the cheerleader.
You know.
Odd, even, right?
Okay.
So this one here, what are the characteristics of this polynomial function? It is what?
Odd positive.
Odd positive. Okay, thank you, Will. And we got to remember that we're talking about odd nature because it's not, as a matter of technicality, an odd function, but an odd-natured function, but positive. And what do we know about odd positive polynomial functions? Where do they start and finish?
At the bottom and go to the top.
Start and end.
I don't know.
And just looking at this, if we graphed it, we'd be in the calculator, we'd be able to see what it is, but we know, and all we really need to know is this thing. We know a thing goes something like this, right?
Yep.
So therefore, the limit as x approaches infinity of f of x is equal to infinity, and limit as x approaches neg infinity of f of x is
Yes.
neg infinity. See, they're going to have to be different because one starts low, ends high. So this is what it's going to be. And that, my young friends of Precalculus, is our answer. That's it. So I want you to go ahead and really 2 through 4 are the same. I'm going to pick somebody for number 2 to show us here, okay?
Wait, how do we, the odd comes from the power, right?
Yeah, okay. Kaylee mentioned it has to do with the leading, this is our leading term, which has an odd power and happens to be positive, as in positive 2, not negative 2. So that's what governs, okay? That was a good question, Kaylee. All right. So now I'm gonna choose some victim here to help us out with number 2. Okay, 2, you should be able to figure out if that's odd positive, even, or negative, odd, whatever. You can figure that out, right? So let's go ahead and open.
Yes, between those two, let's do it.
Yeah.
Oh.
And I didn't see Chloe around
We
today.
need to blow someone off the island today.
Here we go.
I'll jump always sacrificing you.
Oh, it's not we, you're already out.
Kinsey.
This.
Kinsey. All right, Kinsey, what do you think?
Even negative.
So Kinsey says even negative, meaning the nature. Does everybody agree with that, or nobody agree with it, or what?
Good.
I think.
Agree? Okay.
I use that, right?
So I don't know what you did, Kinsey. Did you draw a sketch of this, or did you just solve it from here?
It was just in my mind.
She just got smart.
So what? Just go take us the rest of the way. But to me, this is the piece of analysis that really gets us there. Go ahead.
Limit f of x equals. Infinity. Or negative infinity.
So negative infinity, like that, okay? limit as x approaches negative infinity of f of x is? Negative infinity? Yeah, so what this is going to be a start low and end low, right?
Yep.
So we don't know exactly what it does, but we know it's going to do something like this, right? So there it is. So that is our answer. Now, 3 and 4 lend you some other little complication to this, but using a calculator could help you with 3 and 4. Let me go ahead and work that out. Kenzie. Is this thing here going to have any kind of asymptote?
No.
No, yes.
No.
This thing is going to have an asymptote. How do you know it's going to have an asymptote?
Someone has to.
It's an asymptote.
Pardon me? What is an asymptote? Well, a vertical asymptote is going to be a break in the function. Why do you know it has? Why do you know or suspect it has a vertical asymptote?
Because it has a denominator.
Has the variable in the denominator? Yes.
And it's going to be 2.
And you know the value of that vertical asymptote is 2. All right? Good job.
You're born to get 4 shots. What's this? What?
No,
That's even positive.
Gotcha.
Even positive. Okay, are you ready for me to choose somebody with this? With the, Kaylee's ready. Kitty's ready, Carmen's ready. And Emma looks like she's ready. Jana looks like she's getting ready. All right. I want to shuffle this a couple times. Here we go.
I don't know how fast that ball is actually coming.
All right, Katie was asking like the preliminary questions to it. Go ahead.
Lucky me.
limit expression, positive, infinity, fx, we're going to particle. Or 2x equals 2.
Equals 2.
2, which, no. Greater x is, I don't know what that is.
Negative or positive infinity, that's it.
No, it's not.
This is.
No, this is. Circle, let her do it. It's not.
They're always like it's always
Well, I don't know how to do this.
You know how to do it. Okay. Katie was really good at describing the vertical asymptote. I thought she was ready for this.
Nope.
Okay, let me show you something that happens here. What is this thing going to behave like?
An asymptote. There's going to be
Like a
breaking.
rapid,
Like it's going to be like anything greater than a certain meter.
Okay. Now, what Will said, this thing is going to behave like a parabola, except for the vertical asymptote, right? Will, why did you know that?
because it's x cubed over x, which makes it x squared.
Yeah, so anyway, let's go ahead and work that out. We had the tools to work that out based on what we did earlier in this class, right? So if we put 2, 1, negative 2, 0, 1, right? And so we have this here 1, right? And 1 times 2 is 2, 0. 2 times 0, 0, 0. 2 times 0, 0, 1. So our answer to this is going to be x squared plus 1 over x minus 2. So that's what this is going to look like after we simplify. So Kaylee, what is this going to be for us as far as the, both positive, right? Positive, positive.
Mr. G,
Yes,
don't you tell if it's odd or even by the exponent?
yeah. And it's 2.
So you don't tell by the equation, you just, I thought it was the leading exponent.
But if it has an X on the bottom, then it's gonna take away an X from the top.
Oh, okay.
Yeah, so after you divide it, now, you know, some of you guys were working on stuff, so if you didn't catch this, what I did is I did synthetic division of this thing, and you get x squared plus 1 over x minus 2. And so really that's an even function, even-natured function as it turns out. Okay, good work. Okay, Kate, I'm going to give you credit for that. I thought you made a good contribution nonetheless, and eventually answered the question, and that was a challenging one. Let me give you, I'll choose somebody for 4 in a second. All right. Okay, let's see here. I'm going to shuffle this around a couple more times.
Yeah.
Here we go. Looks like Carmen. Right?
Dang it. Yay, Carmen, you can stay another day. Congrats.
All right, Carmen, what do you think?
She said she's ready to go. She said
She might be
she
getting
has
ready.
odd positive written on her paper.
Odd positive, okay. Okay, odd positive. Carmen says odd positive. And I know that because Kinsey read her paper. Okay? And so
I was just hoping.
how many, do you agree with Carmen's assessment of this here?
Yes.
Yes.
Okay, Emma does, yes.
She's just a good guesser.
You're helping her out, but now you're not helping her out, okay.
Helping her out by throwing her under the bus.
All right,
You have to do kind of this one in the last one.
I'm saying, why is yours the?
There's an ABC.
I don't know if we got this right.
okay, Carmen, you got it now?
No, she moved on.
Let me think.
Yeah, now you don't know. Shut up. Oh, it's gonna be infinity. The graph works infinity.
No.
Where? Top one. Is the top one infinity? Yes. Got it.
Is the top one infinity?
Yes.
Okay, what's
Is the
this
bottom
one?
one negative?
Negative infinity, right? Why is that gonna be?
Go up and down.
Odd positive, right? Odd positive, starts low, that's where that negative infinity comes from. Ends high, that's where that positive infinity comes
I'm gonna kick you up out of the
from. Okay? So that's what that is. Thank you, Carmen,
No.
and others who helped Carmen.
excited about that.
We
Mr.
excited.
J, I have a question.
Yes,
No.
So,
You did it, now I'm
me and Will put the exact same equation into our calculator, but the graphs ended up different.
for this one here?
Yes.
Well, it might have to do with, let's see the types of calculator. Both of you have the same type of calculator, right? Okay, let's see what I have up here. Or can I just see your calculator, see what it looks like?
Wait, does yours look weird? You wanted to know,
You
right?
just have you had a vaccine for tuberculosis.
This is what I imagine it should look like, but it looks different.
Yeah, mine doesn't look like that either.
Yeah, let's see here. Let's see, I gotta get up close to see this.
Bleach. Zoom out.
Zoom.
Blue.
Press
What
zoom.
color was it originally,
3.
right? No, it was blue.
Zoom 6.
Wait,
So you down
Before it's blue?
and it said cool.
alright.
We're gonna try that. It was blue.
40 on all.
And you're gonna have a, let me get this here. Should be an asymptote -1.
I've been tested 3 times and I know, you might still have it, you haven't had that third test.
2 squared.
And you might still have it.
I might. You don't want it, so you might wanna go get a drink somewhere else.
I do want it.
But I don't want you to have it, because the bogus, yeah, I got it. Wait, you're gonna go to COVID? What are you talking about? I wanna punch you in the face right now. I wanna punch you in the face.
If I had it, I wouldn't be here.
I'm gonna punch you in the face.
Okay, what it is, it's not quite, it's negative here, so
Emma, I
it has
love
to be
you.
the dimension of the graph here. So if we change this here,
My window is negative 44.
okay, so she just changed your window, so you didn't pick up the one on the left. Will says you got negative 44, I'm gonna make it negative 20, 20. Let's see if this picks it up.
This?
Adam got it.
I don't really have a zoom, I have
So you
a,
can kind of see it a little bit there, the negative 40, 40, you can kind of begin to see it. So the dimension of the window didn't allow you to see what he sees essentially. Okay, that's a good question.
Because Emma, I have more important things to do.
I don't really have a window view, I just kind of zoom in now.
Okay, next, 5 through 8, combine the fraction, reduce your answer to lowest term. Should I just call on somebody for this, or should I?
It should be.
Work out.
Okay, here, on this one here, so happens that 6 is very similar.
Yeah, go back. Go fish.
No.
No, yeah.
Circle when you-
No, yeah.
There it is. Okay, what happens, our common denominator is going to be x. So this one right here, how do I write x squared as a common denominator of x?
X to the third over it.
Yeah, I just make it as, I multiply by x over x. And so now, what I have is I have x cubed over x plus 5 over x, which equals x cubed plus 5 over x.
Wait, why wouldn't the x's cancel?
Well, they do cancel,
But
but
after you add them.
what it is you designed it not to cancel, so that you could add these together as a common, over a common denominator. Yes,
Would you like to go get some hot chocolate?
oh, I already had some. Thank you, Charlotte, appreciate it. Okay.
Gene, Mr. Gene, shoot out that some.
I should have said yes.
Yeah, you
You
should
got
got
so many
some.
hot chocolate.
Yeah, you really should have.
Oh, I got another idea that'll be just as good, I'll tell you that in a
Are you
minute.
gonna go bring us hot chocolate?
No, it'll be a different thing, but I'll tell you.
Salsa!
No, it won't be that. Okay, I'm gonna choose somebody for 6.
No, go, yeah, go back.
I didn't get the answer down.
It's x cubed
I'll
plus
suck it.
5 over x.
Right here.
X
It's
squared plus 5
That's
over
wrong.
X. Yeah, chill.
Okay, so I'm gonna pick somebody for number 6.
I was kidding.
Okay, I'll shuffle a couple times, 3 times.
Okay, Mr. G, once we're done with this paper, you still gotta go until we get one last person so we can eject someone else from the island.
Oh, really?
Yeah.
Eject them.
So we got Jane.
He's already out.
We got you. Okay, Jane is gonna do that for number 6. Okay, Jane, what'd you get?
Hey, pass your paper. Well, pass your paper.
You're looking at
Times x over x
Okay.
minus 3x,
Two answers on that one.
which would equal x squared over x minus 3 over x, which would equal x
this one is for this one,
to the
and
third
this one.
minus 3 over x.
This one, and this one, and this one. Okay.
Like this?
Yes.
Okay, this is what Jana got. Did everybody get that?
Yes.
Wait, what was the answer to the last one?
X cubed minus 3 over X.
Here, thanks.
Mr. G, I have a question. When you have the two x's on the bottom, so why would it be x squared?
Well, what it was x squared, but we had to get our common denominator. How do we get a common denominator? Multiply this by x over x. And so now, you multiply these numerators together, you get x cubed.
No, I'm talking about the one on the bottom.
The one from the bottom,
Yeah.
It's common on.
They're like, no, they're talking like.
that's a denominator. That doesn't change.
Oh, okay, never mind.
All right, so you okay on
Yeah,
that?
for sure, I was right.
Okay.
Unless I'm not right.
All right, number 7. Is somebody ready for 7, or should I spin the wheel on 7?
Ready for 7.
Let's get it. Let's do it.
Spin the wheel on 7?
You just cross multiply or what?
You can do it that way. As a teacher, I like to go ahead and set it up that you use your common denominator.
Armin said she goes.
No, that way.
So should I spin a wheel on this one?
Yeah.
No?
Go for it. I think you should do it.
I say go
Full
ahead.
spin, all the way.
Let's go
Yeah,
ahead.
let's go ahead.
Yeah, then you can help each other with it.
And by that.
Okay, here we go. Couple shuffles. Angel.
Well, I guess he doesn't get ejected today.
Okay, next.
Keep going, keep
Gonna
going,
be
keep going, keep going.
Kayla.
Okay. For 7?
7.
I said James.
Unserved? Yeah, you're not on the
Yeah, we're not gonna kill you.
You're not dying today, Caleb.
I don't want to. Wait, what are we supposed to be doing with this?
Number 7.
Yeah, but we just put it like that.
I think Adam wants to be ejected.
Puzzle.
I'm gonna
I'll
jump
just
off
wait
the
for you
ladder.
to write that.
Well, I'm gonna be ejected. I'll be back.
Wait, Will, what'd you get?
X squared is x
No?
Wrong. Hey, Jane.
Did the common.
Hey, girl.
That's what I did too.
Okay, you need me to start you out on this? Or do you have this one done?
No.
Do you need me to start you out on this?
Yep.
Okay, what I'm gonna do for this one here, I'm gonna let Kayla finish this for me, but I'm gonna start out.
You're black.
No.
No,
Well, yeah, mine.
So to get our either common denominator of this, I have to multiply both the numerator and denominator by x minus 3, right?
I already have the work done. That doesn't mean I can complete it. I keep going wrong somewhere. I don't know where it is.
Okay, so Kayla, that's a start. Is that a helpful start?
I already have it.
You already have that, okay. What else? What next?
Do it together.
Okay, so we got 2, we got x minus 3 here, and then we do what with this?
I didn't know you did it. I'm there to talk to you. I know you talked to me.
What do we do with this one to common denominatorize it?
Wait, no, I definitely did. You tried to multiply it by 2x plus 1.
So here and also here?
Previous class.
Okay,
In that class when I had to do.
so that's the hard part of it, right? So what next when we simplify what's in our numerator?
Adam that looked
Like
Wait,
this?
It wasn't you that was, everyone was like
Yes.
running into the classroom trying to get the seats because they said
It
no
wasn't me.
seat, no seat.
I was in the desk right behind.
I thought you were the
I
one.
tried to help, but I was laughing too much.
X squared.
I was sitting there laughing.
Wait,
Like
was
this?
it? I think it was.
It was Kenton.
I'll take over
With you.
And then,
Minus 4x minus 2.
and that's all over this here, like this. X minus 3. And then we can finally, what does this become here?
X squared minus 7x minus 2.
Thank you, Caleb.
Find the video. It's not of me being like split, it's just of me sitting on the floor.
And then this right here, right? All right, is that our answer?
Yes. And you times the bottom together, or do you leave them like that?
You can just leave them in factored form. Usually I just leave them in factored form. And what it does is if you leave it in factored form like this below, it connects with the beginning better, I think. Then you can see that, yeah, that's related as a common denominator. So I would just leave it in factored form. That was actually a good question though. Okay? Good work. Okay, now I'm going to spin the wheel for number 8 too, right?
Alright. Might need a second, but okay.
Yeah. Second here. Kayla was working on it. These exercise sets, Kayla's been doing great on these recently. Okay. So let's do this shuffle a couple times. Here we
Yes,
go.
We're getting closer to ejecting someone. Can we eject you? No, can be dirty out. Yay, Emily gonna stay another day. So it's Adam.
So what do we got here?
40 else getting ejected. 40 else. Oh. Anyway, so.
Qu'est-ce que nous avons acquis, Emily?
Hold on, I'm almost.
She's almost ready, she says. What do we have? What do we have here? Qu'est-ce que nous avons ici? What do we have here?
Okay, you're gonna multiply the x, your x minus 4.
And then,
And then, so you're gonna multiply both of those by their x minus 4.
like this.
Yes.
And then we have plus,
And then multiply both of those by x minus 1.
so x minus 1, x minus 1. And then we have to do this too, right?
Yeah. They're gonna distribute the x on top and get 3x squared minus 4x.
Okay.
Plus, and then after each times of those, you're gonna get x squared minus 1 over 3x minus 4 times x minus 1. And then you'll combine like terms and get 4x squared minus 4x minus 1 over 3x minus 4 times x minus 1.
So is that it?
Nope,
Yes.
Nope. Why not? Why?
lowest terms.
To me, that looks like lowest terms. Explain if it's not.
Well, the denominator, if you distribute out,
Oh wait, why would you take away the x minus 1 and the x minus 1?
To me, this looks like lowest terms.
I mean, if you work it out, it's 3x squared minus 7x plus 4.
Okay, so you distributed this. Now,
Yeah.
yeah, you could do that. What Will did is he distributed out and wrote it in different forms. You can just leave it in factor form too. It's not incorrect to distribute the denominator, but this is actually an acceptable answer. And I think that's the way the book has it. I'll show you the way the book has it. Not that that's the way it has to be, but. Okay, the next, we're looking at 9 and 10. List all the possible rational zeros of the polynomial and factor the polynomial completely. What is that going to be?
But I put 6 people so far.
What do you mean do it first?
Okay. Okay, Will, I gotta give you credit because the book did it the way you did it.
Okay, Will.
Does that deserve a sticker?
Yeah, you do, just because the book did it your way. You agreed with the author of the book.
I just like takes you over.
Oh, what about this one here? Do you have an idea how to do this one?
Do you use synthetic division
Well, we could use synthetic division. There are different ways of doing it.
or factoring?
Or factoring, or remainder theorem.
Yeah.
So there are different ways of doing it, but actually it's part of factoring. But what are the possible rational zeros?
Plus or minus 1 or plus or minus 3.
So we have plus or minus factors of 3, which is 1 and 3, right?
Yep.
Over factors of 2, which are 1 and 2, right?
Yeah.
So the list of rational zeros is going to be plus or minus
1,
1,
plus or minus 3,
minus 3,
plus or minus a half, plus or minus 3 over 2.
so those are our possible rational zeros. And how do we use it here to get this one?
Synthetic use the 5 by 1 of
Yeah, you can use synthetic division. You can use remainder theorem. We have a pre-calculus student in 5th period, Elizabeth, who actually used the box method to factor out, which was really pretty amazing.
Do you use synthetic division?
Yeah, the only thing is, the only difference is you got bottoms of that 2.
Hannah, you pause that one.
2x
Okay.
minus 3. Yeah, 2x minus 3. How did you do it? So you just did it in your head?
I found it on the graph.
How did you know that x plus 1 was
I
going
went to the
backwards?
graph.
You graph?
I went to the graph.
Graph. Okay, and you saw the zeros?
Yes.
Well, it's to the third, so that means
It
there's
didn't
3
work.
factors.
Okay.
Negative?
Oh, wait, I did positive.
Which way do you want to try? You want to try synthetic division, or you want to try remainder theorem, or do you want to try what Elizabeth did?
Remainder
5th period?
theorem.
Remainder theorem?
Yeah, what is that?
Let's try remainder theorem. In remainder theorem, we test out the factors. So we're going to say we're gonna say like if f of x
Yeah, that one works.
is equal to 2x cubed plus x squared minus 4x minus 3, we can test our zeros by plugging in, right? So if we put if we try 1 as a 0, f of 1, what do we get? Well, we get 2 times 1 cubed, right? Plus 1x squared minus 4 times 1 minus 3. And so what is that going to be? It'll be negative 4. So is 1 a 0? No, it's not.
They're -1.
So now we're going to try negative 1. So we kind of just go down a list. And so now we plug in negative 1. So 2 times negative 1 cubed plus negative 1 squared minus 4 times negative 1 minus 3. What is that going to be?
0.
So we have negative 2
Yay.
plus 1 plus 4 minus 3 is going to equal 0, right?
Yeah.
And so there we know that's a 0, so what does a factor have to be?
X plus
So x plus 1 is a factor. And then how do we tell what the rest of this thing is? We can go here, right? Put 2, 1, negative 4, negative 3. And so we get 2, and then we get negative 2, negative 1, 1, negative 3, and 0. So we get 2x squared minus x minus 3, which factors into x plus 1. And that's going to be, what do you say it was, Kayla? 2x minus 3? So this will be the factored polynomial here.
But you wouldn't put the x plus 1 twice, would you? X plus 1 squared.
Yeah, you could put it twice, or you could just make it as 1 squared. Either way, yep. So anyway, that's it. I know we haven't finished 10 quite.